Okay, in this video, I'm going to discuss about rules of inference, which, from an examination point of view, I feel is important, and you can definitely expect one question on using rules of inference to uh, validate a conclusion, right? So, to answer like questions on based on rules of inference, you need to like know all these rules, like one, two, 3, 4, 5, 6, 7. There are 8 inference rules, all of which you need to by heart because those are the rules which you will apply to make a valid conclusion. So, like, we'll start with this example and then we'll work on other problems as well from the model question paper. So, this one here, this the structure is like this. You'll be given a set of arguments. So these here are a set of arguments, or you can also call it hypothesis. So these are assumed to be true, right? And then in the end, you have a conclusion. So this is called a conclusion. Now, this conclusion, we don't know whether it's true or not, but the question is saying that we have to use these hypotheses or arguments to which will help us conclude that this is true. So that's what we have to do. Now, if the question is in the form of English sentences, then what you need to do is convert those into propositional variables and propositional statements. So, so that it looks like these, where you can apply the rules of inference. So, in this particular case, like the first sentence saying it is not sunny this afternoon, and it is colder than yesterday. So, when you choose your propositional variables, it's generally we uh, choose positive with uh, the positives as the propositional variable. So, for example, we can choose P as 1 second. We can choose P as it is sunny, right? So, which means 1 second. Okay, P can be used to represent it is uh, sunny, right? So my pen is acting. Let me just fix that first. Okay. So P is sunny, which means not P will be uh, not sunny, right? Not P will be not sunny. Okay. Now the other fact is that it is colder than yesterday, right? So again use Q for that. So this means colder than yesterday. So I'm not writing the whole thing. So sunny means it's we're talking about today afternoon, and colder means I'm talking about yesterday. So not Q means it's not colder than yesterday, right? Then if we do not go for swimming, so if we go for swimming, we can represent S as we go for swimming, right? And the not S will be will not go for swimming, right? So I'm just writing it as no swimming. So for exams, you have to like write the full sentences and not just how I'm writing here. I'm just doing that to like save time. So now the other thing is canoe trip. So I'll represent that as C. So which means I'll go for canoe trip. And not C will be I'll not go for uh, canoe trip. Right now, do we need anything else? Okay, we need one more thing. So it says we'll be home by sunset. So we can represent that as T. So which means we'll reach home by sunset, and not T will not reach home by sunset. Okay, now since we have now got the variables, our task will be to convert these sentences into representation using these variables. So it is saying it is not sunny this afternoon and it is colder than yesterday. So it is not sunny. So hmm, that is not P. It is not sunny, and which means it's this operator, and it is colder than yesterday, which means it we have to do Q, right? So that's my first premise or hypothesis or argument, and this is true, right? Now the next argument is we'll go swimming only if it is sunny. So this means that now you have to be careful with these type of sentences because it says we'll go swimming only if it is sunny. So the natural tendency will be to write it as if it is sunny we'll go swimming, but that's not what it says. It says we'll go swimming only if it is sunny, right? So it doesn't mean that if it is sunny you will go swimming. If you go swimming, then it is sunny. So it's actually if we go swimming, then it is sunny. That's the proper form of that. So if we go swimming, then it is sunny. Is an implication. So swimming is S. So S implies. So which means we'll go swimming implies it is sunny, which is S. Okay. What did he swimming as and what was sunny? Sunny was P, right? So S implies P, right? So now third one. If we do not go swimming, which is we are talking about not S, then we'll take a cannot trip. So that's straightforward. So if we do not go swimming, then we'll take a cannot trip, which is C. Now the fourth argument is if we take a cannot trip, so which means C implies we'll be home by sunset, which means it's T, right? Now these are true, and these are the arguments, and the conclusion that we have to make is we'll be home by sunset, which means we have to conclude we should be able to conclude that T is true. So we will do that by applying these rules of inference. So let's start with so there are different ways you can do that. Now you can also think about like for T to be true, C has to be true. So for C to be true, S has to be false, uh, right? So like we can always reason backwards, but we can also like start from the first statement and see if we can do anything about it. That's also the proof strategy that we can use. So I'm just going to start from the first statement here and see if we can I can go about proving like solving it. So first one is not P and Q. So if I look at the rules of inference, right? I have to search use the rule of inference which is similar to this. So here this looks similar to what I have here. So not P and Q. I can conclude either P as true or Q as true, right? So that's called simplification. So here I need P here, right? So I'm going to conclude that uh, P is true, or I will conclude that not P is true, right? Mm, I'll conclude not P is true. So the reason is simplification, right? So I have to write that rule of inference here. Simplification using 1. That's the reason for concluding that not P is true. So now if you look at now you can take the second one. So second one is saying S implies P, right? So is there anything that you can is there any other rule that you can use here? Now look at the second one, like this one. What is that saying? That's saying P implies Q, and if you know that Q is not true, then you can conclude that P is not true, right? So here, if you look at 2 and 3, right, it looks similar because S implies P, S implies P, right? And the right hand side, is not true because not P is true, which means S, we can conclude that not S is true, right? Not S is true. So I'm using modern Stallings and I'm using statements 2 and 3. So you have to, on the right side, you have to give the reasons for why you're making that conclusion, right? Then, okay, now what can I do? So I now know that S is not true. Now look at the third one. So third one is saying not S implies C. Now if you look at which rule you can apply this rule here, right? Because you know that the left hand side is true and left hand side implies right hand side, so you can conclude right hand side is true. Here I know that not S is true and not S implies C, which means I can conclude C is true, right? So I got C is true. And now for all these given statements, you can just write like given or premise. Like here you can write premise. Now C, the conclusion C is the reason is we are using modus ponens again. Modus ponens. So modus ponens using 4 and 5, right? Then 7. The fourth statement, right? C implies T. Now, I can again use modus ponens because I know the left hand side is true. And so using modus ponens, I can conclude T is true, right? T again, modus ponens using 6 and 7. And so that's the step by step way of applying rules of inference to validate a conclusion. So if you are given, sometimes the question is just this, like you'll be given. Sometimes the question is just this, which means you'll be given, this, right? So if you're given this, then you can just directly go ahead and apply all the rules of inference to validate the conclusion. Sometimes it's the sentences that are given, in which case you'll have to first convert this to this and then validate the conclusion. So in the next video, I'll discuss another problem, uh, like a different type where you have to follow a different approach, and also a problem on predicate logic.